This is the new year, 2024, and it's closer to exam time. So stay tuned with us as we explore more on our CSEC syllabus, helping you guys to reach the highest level in your exams coming this year or in the future years to come. Hi everyone, welcome to another lesson at the CSEC Chemistry at EDU Solutions Institute. In this lesson, we're going to look at the basis of the mole concept. And I know the mole concept is a very challenging topic for students over the years of doing chemistry. Now, I'm going to try as best as possible to break down this concept in the simplest possible way so you can understand and appreciate the love of the mole concept and its function in our world today. Now, we're not going to talk about the mole today. We're going to look a little bit more on the basic part to lead up to that challenging aspect. So stay tuned as we explore the mole concept together. Now, the mole concept is going to be, as I said before, broken down into different parts. Now, in today's lesson, we're going to look at these three terms. Now, the first term is the molar mass. Molar mass. And the molar mass just tells us is that if we have a substance and its value is 1 mole, then it is how much mass is present in that 1 mole of the substance. So you can put into play, instead of saying the word mole, let's use the word liters. So let's say we have a cup of water, and we say in this cup of water, it is 1 liter. Right? So we have a volume of 1 liter of the water. Now, when I talk about molar mass, if we say 1 liter represents the mole, then what I'm saying is to find the molar mass is I put this on a balance and then I say how much mass does this 1 mole, this 1 liter of water occupies or have. So that's what our molar mass is. Now it's represented in a unit of grams per mole. So it shows us that it's the mass which is represented in grams divided by the 1 mole of it. Alright? Then we look at relative mass. And relative mass are the masses that we see in our periodic table. So when we see hydrogen in the periodic table, and we see that it has an atomic number of 1, and we say it has a mass number of 1. This 1 at the top here tells us it is the relative mass. And the relative mass, how did we get that number? It is based on the principle that we compared 1/12 of the mass of carbon-12 to this element hydrogen. And when we did that calculation, then we got a ratio of 1. And that's why it's called relative, because we're relatively comparing hydrogen to carbon-12. Right? So that's how all elements in the periodic table has a mass number. Right? And that mass number is called the relative mass. And it's represented not in grams, but in a unit that is called AMU. And AMU is called atomic mass unit. Right? Then finally, relative formula or molecular mass. And this relative molecular mass or formula mass is the total mass of all the elements that are present in a compound. Alright, and this is where we're going to look on a little bit more today. So let's go. So let's use the basic one of water. And we know water's formula is H2O. From this formula, we see that we had 2 hydrogen combining with just one oxygen. Now, to find the relative molecular mass, what do? We first identify how much elements are there, right? So therefore we know that there are 2 hydrogens and there is just 1 oxygen. The next step is we look at our periodic table and we see what's the mass of hydrogen, and we know the mass of hydrogen is just 1. Then we look again, what's the mass of oxygen, and we see that the mass of oxygen is 16. So therefore what we do is to multiply that. We have 2 hydrogens, so we multiply it by the 1 mass for each hydrogen, and we have 1 oxygen, so we multiply it by the 16, which is the mass of oxygen. So therefore the RMM value would be that it is 2 times 1, which represents the hydrogen, plus 1 times 16, which represents the oxygen. So this would be 2 plus 16, which would give us 18. So what we now know is that the total mass of water is 18, and that is the relative molecular or formula mass of water, right? And this is relative because remember, we're comparing it to carbon-12. Let's try another one. So let's go with sodium carbonate. Right? So again, the first thing we do is to identify the different elements that we have. So we have sodium Na, carbon C, and oxygen O. How much sodium we have? We have 2 sodiums. How much carbon we have? Just 1. And we have 3 oxygen. So from here, we look on our periodic table. Right? So our RMM would be equal to 2 times the mass of sodium, which is 23, plus 1 times the mass of carbon, which is 12, and finally plus 3 times the mass of oxygen, which is 60. So here we have 2 times 23, which is 46, plus 1 times 12, 12, and then 3 times 16, which is 48. When we add this up, we get 106. So 106 represents our relative molecular mass or formula mass of sodium carbonate. Now before we go, let's do another one. So we're going to do one that requires us to expand the bracket. So we're going to look at aluminum nitrate. Alright, so aluminum nitrate. So again, we identify the elements present, Al, N, and O. Next, we see how much Al we have. We just have 1 Al. How much nitrogen? We have 1 here, but it's totally multiplied by 3, so that's just 3 here. And then for oxygen, we have 3 here, but it's also multiplied by 3. So therefore, we have 9 oxygen. So therefore, that goes to say that the relative molecular formula mass is going to be equal to 1 times the mass of aluminum, which is 27, plus 3 times the mass of nitrogen, which is 14, plus 9 times the mass of oxygen, which is 60. Right? Then 1 times 27, so then 27. 3 times 14, that is 42. And then 9 times 16 would be 154, so that's 144. Then we add all these numbers together. So this gives us 186. 206 plus 7, that's 230. And here we have that the relative mass or relative molecular formula mass of any compound can be easily attained by just knowing what the mass of each element are, how much elements are in this specific compound, and just add these masses in total to give us the total mass for each compound. Now that's it for today. I hope you understand, learn something new, or just a reinforcement of what you already know about relative molecular mass, or relative mass of elements, or just the molar mass. So stay tuned. Next week we're going to look at the deeper depth of what is a mole. I hope you enjoyed today's lesson. So stay tuned and I'll see you next week where we learn more about the CSEC Chemistry syllabus here at EDU Solutions Institute. Thank you.